So just between section 11.7 and 11.8, there's a couple of notes here. First of all, we've now learnt to do all the integration that we're going to be able to do. We need to apply it in different ways, but what you'll find is that we have a lot of different methods here, and it's helpful to stop and think about which methods to apply, because often the difficult bit isn't doing the integration. The difficult bit is finding the right pattern, finding the right method to use. You'll be struggling for ages trying to do an integration by parts and suddenly find that, oh, I could have just used a partial fraction instead. Or you'll be struggling trying to do a partial fraction and realise that actually it's a reverse chain rule or something like that. The way that I would recommend you do it whenever you come across any integral is work through them in this order. Now the special patterns is what I like to call them special patterns. In this book they're called the reverse chain rule, which is the things, I can't remember what section it's in now, but it's the things of this form: f of x divided by its derivative, or a function of x to a power times by the derivative of the function. Okay, when you're integrating something that looks like that, that's what I call a special pattern. When you've got this pattern, then you can do it. You've got this pattern, then you can do it. And you know that this one you try natural log of, oh sorry, the derivative's on the top, isn't it? You try natural log of the function on the bottom, and this one you do this function to the power of n plus 1. Okay, so try that first, because if you don't, you won't spot it. Okay, so most integrals, you're not going to use those special patterns, but get into the habit of when you see an integral, just check, is it a special pattern? Because if it is, you can get the answer in a line. If it's not a special pattern, you're going to have to do something that's more difficult. Okay, so try the special patterns first. Standard integrals, what I mean by a standard integral is one of these off our list, right? Is it one of these, 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 all right? Or something that can be rearranged into one of those quickly. And is it one of those where instead of an x, I've got a linear function of x? So often you can be looking at it and you all the different kinds of integration are spinning in your head, and it turns out actually it's just sec squared of 3x plus 2, and you didn't realise that you can integrate sec squared to tan and divide by the coefficient of the x, all right? So standard integrals, check for those next. Check special patterns, check it's not a standard integral. Now, if it's neither of those things, then in some ways the choice is sort of narrowed down quite a bit now. First of all, try trig. And when I say trig, I mean try your trig identities. Try and mess around with the trigonometry. Now, it should be pretty obvious if that's the case, because if it's not one of these and it's not one of these, then it's some trigonometry and you need to rearrange it into so you get one of these things that we can integrate. Okay, so try trig identities next. If that didn't work, partial fractions. Now, obviously, you're not going to try trig and partial fractions, because if it's got trigonometry in it, you're going to try trig. If it's got partial, if it's a load of polynomials, one divided by the other, then it's partial fractions. But those two things kind of come next. Once you've exhausted all that, and not until you've exhausted all that, head to parts, okay? Now, you might spot something and you think, oh, that looks like parts, right? Because it's a product of functions, and if it's a product of functions, I should use parts, and I'll go straight to parts. It's only going to take you 10 seconds to think through these things. Often, you'll try a parts one, and it's not. It's a special pattern, all right? So, or it's something you can simplify with trig. So don't zoom into parts too fast, because if you do, you'll spend a lot of time getting tangled up, and sometimes, of course, you have to use parts and then use it again. And so you can try and use parts twice before you realise actually you're on the wrong track and think of something else. So think through them in this order. And the reason I put substitution at the bottom is because most of the time you will be given the substitution to use. So if you're using substitution, mostly you won't need this list at all. This list is for if you have an integral and you don't know how to do it. If it tells you to do substitution, you're not in that situation. You have an integral and you know how to do it. They've told you to use substitution. So special patterns, special integrals, trig, partial fractions, parts, substitution. That's the order you should try integrals if you don't know how to do them. Now, I've written it out like this, and you can see you've got this collection of letters. So there is, it's up to you to then try and make a mnemonic. I can't remember, it wasn't a very good mnemonic, is it? Because I can't remember what it was, but I think mine was, some people still insist that Pete finds, and then I can't remember, so, I don't know, pancakes satisfactory. There you go. Some people still insist that Pete finds pancakes satisfactory. That's your mnemonic for that. Now, you might want to change standard patterns into reverse chain rule. So you're trying to remember R, C, R, S, I, T, P, F, P, S. Or maybe you can, maybe you're cleverer than me and you can just remember those things in that order. Up to you, but that is what I'd recommend if you're trying an integral and you don't know how to integrate it. Those are the techniques that we've got. Try them in that order, and you should find a method that works.